Hello everyone, this is Abhishek Datta and you are watching my YouTube channel Mathematics Made Easy. Today our topic of discussion is the theory of probability. Now probability, as you all know, is a very interesting topic. It has its wide applications in various branches of mathematics as well as in statistics also. This is the only topic which is widely used both in mathematics as well as in statistics. Now, to understand the concept behind probability, one must first understand the concept of a set, because the entire theory of probability is based upon the concept of sets. So let me in short explain what do we mean by a set. I'm sure that you all must be acquainted with the term set. So basically a set means a collection. It is a gathering, a collection of some objects or a gathering of some objects. That is a set. And in day-to-day life, we often use the same term sets. Likewise, sets of pens, sets of students, sets of chairs, sets of tables. But there is a fine line of demarcation between the day-to-day terminology set which we use in our day-to-day life and the term set in mathematics. There is a very fine line of demarcation. So let me explain that. Now basically set means the idea of collection, the idea of gathering. Whenever we have some collection of objects, we call it a set. Now in mathematics, these objects or these elements of a set must satisfy two criteria. First of all, they must be well defined. The objects of a set must be well defined. And secondly, they must be distinct with respect to each other. So these are the two criteria which the objects of a mathematical set must satisfy. Number one, they have to be well defined. Number two, they have to be distinct. Now it is easy to understand the second property, that they have to be distinct, which means any one member must differ by at least one property with any other member of the same collection. So we call them distinct members. Now what do we mean by well-defined members? By well-defined, we mean that given a collection in advance and given an object, given a set or a collection in advance and given an object, if we can conclude without any hesitation that whether this object belongs to the given collection or not, then that collection is said to be a collection of well-defined objects. So without any doubt, if one can conclude that whether the given object belongs to the given collection or not, in other words, if it is a member of the collection or not, then that collection is said to be a collection of well-defined objects. For example, if I consider the collection of alphabets, collection of all 26 alphabets from A to Z, and if I give you a number 7, so you can clearly say that this cannot be a member of the set, because the members are the alphabets of English. And 7 is a number, it is not an alphabet. So it clearly doesn't belong to the set. So the set of all alphabets of English literature forms a well-defined set. The objects are well defined. Again, if we consider the set of first 5 alphabets, A, B, C, D, E, the set of first 5 alphabets, and if I now give you the alphabet Z, then also you can surely say that this alphabet doesn't belong to that collection, because the collection have first 5 alphabets, and we know the first 5 alphabets are A, B, C, D, E. Z doesn't belong to that. So here also the members are well defined. Now, when the members of a collection cannot be said to be well defined, likewise, if I say set of stars, in English literature we often use the term set of stars in the sky. Now, set of stars, if you look towards the sky, there are numerous number of stars, all looking alike, because from a huge distance they all look like points. Now, if I mention a set of stars and a single star separately, then it is not very easy to understand that whether the single star in our discussion comes from that group of stars in the sky, because they have similar appearance. So these objects are not well defined. Even if we have 2 Parker pens, say this one, if we have 2 Parker pens, same identical Parker pen, then mathematically this is not a set. Because unless there is some mark or something, unless I make some mark or something, we cannot distinguish between the two. That if I give you any one pen in advance, and if I say that this pen belongs from a set having 2 pens, both identical, and you have to guess which one of, either it is the first one or the second one, then it is not possible for you to guess, because they look alike. So in spite of being a collection, here the members are not well defined. Not well defined means they are not distinguishable, either by their shape or size or color, or by their appearance, or by their characteristic. By characteristic we mean alphabets, numbers, these are characteristic. Likewise, a number cannot belong to alphabet set, because they have different characteristic. The former is a alphabet, the latter is a number. So therefore, any collection of well-defined and distinct objects is a set. Now, in probability, what is probability? Probability is the study of chance, the study of chances. To study probability, we first require some basic terminologies. These terminologies are frequently used in the study of probability. Let me explain them one by one. The first one is random experiment. Random experiment. You have to deal with this term, random experiment, almost in every article of probability. So what is a random experiment? Experiments are of various kinds. Some are biological experiments, some are physical experiments, some are chemical experiments, and some are statistical experiments, and we also have random experiments. So what is a random experiment? Random experiment is such an experiment whose all possible outcomes are known in advance. All possible outcomes of the experiment are known in advance without even performing the experiment. Mind that. Without even performing the experiment, all the outcomes of the experiment are known in advance. But it's not possible to predict that which of the outcomes will occur at a particular trial of the experiment. You know all possible results even before performing the experiment, but you cannot say that which of those outcomes will occur at any particular trial. Let me illustrate this. See, if I consider tossing a dice, You know, a Ludo dice, tossing a Ludo dice. So a dice have 6 faces, 1, 2, 3, 4, 5, 6. It is a cubical shape object having 6 faces, you all know that. So if I toss a dice, if that is the experiment of tossing a dice, so without even tossing, we can say that any one of the numbers, either 1 or 2 or 3 or 4 or 5 or 6, will come up. So we know all possible outcomes, that from 1 to 6, either one of the numbers will occur. But we cannot certainly say that we will get a 6, or we will get a 1, or we will get a 3 likewise. We cannot be 100% certain about that. That in a particular throw, 6 will occur, 100% assurance. Nobody can say. But yes, we have an idea that 1, 2, 3, 4, 5, 6, these 6 outcomes shall be there. Whereas in a physical experiment, it is not so. Likewise, say if I consider to measure the temperature of a body. So unless we actually measure the temperature, we have no idea about the possible outcomes. In the previous case, all the outcomes were known, 1, 2, 3, 4, 5, 6. But here, unless we measure the temperature, we cannot say, or we cannot define a limit that the temperature will lie between this and this. We cannot define unless we measure the temperature. We cannot say the temperature will vary between 10 degrees Celsius to 30 degrees Celsius. We cannot say unless we measure it. So here, we don't even have a clear idea about the outcome unless we perform the experiment. Whereas in the previous case, without even performing the experiment, we know the all possible results. So such an experiment is said to be a random experiment whose results are all known in advance without even performing this. But obviously it is not possible to predict which of the results will occur at a particular trial. So such an experiment is a random experiment, and our probability theory holds only for such random experiments, not for any physical experiment, not for any biological experiment, not for any chemical experiment. It will hold only for random experiments. That is, experiments which has this property that all the possible outcomes are known in prior. So this is the first important point which you have to deal in the study of probability about random experiments, about their nature. So there are many examples of random experiments. Likewise, I just said tossing a dice or tossing a coin. If you toss a coin, then also you know either head or tail will come. But among the two, which one will occur at a particular toss, that is unpredictable. So it is a random experiment. Now the next term which frequently occurs in the study of probability is event, an event. What we mean by an event. And even before that, the collection of events, that is sample space. So let me first define what is a sample space, and then we shall define what is an event. So after random experiment, the next topic is sample space. So sample space is nothing but a set that is the collection of all possible outcomes of a random experiment. It is just the collection of all possible outcomes. So that is the sample space, the gathering or the totality of all possible outcomes which a random experiment will produce. That is the sample space. An event is any one outcome of this sample space. Any one outcome of the experiment is an event. So if I toss a dice and I get a 6, then this is an event. If somebody gets a 5, that is another event. So a single outcome is an event, whereas totality of all possible outcomes is the sample space. Now these events, as we are discussing here, are of two types. One is simple event and the second one is compound event or multiple events. Simple event and compound event. What is a simple event? A simple event is an event which can occur in only one way. Which can occur in only one way. Likewise, if I throw a dice and if the condition is, if 6 occurs, then I will win. If 6 occurs, then I will win. Then I can win in only one way. That 6 has to occur. There is no other way that I can win. So that is a simple event. An event which can occur in only one way. Whereas a compound event is an event which may occur in more than one ways. In more than one ways. How? In the same context of tossing a dice, if I now put the condition like that if an even phase occurs, then I will win. If an even phase occurs, then I will win. Then you see, there are 3 different ways of which I can win. Because out of 1 to 6, there are 3 even phases, 2, 4 and 6. If 2 occurs, I win. If 4 occurs, then also I win. If 6 occurs, then also I win. So here, I can win in 3 possible ways, in more than one way. So such an event, even phase occurs, is a compound event. And the event 6 occurs is a simple event, because that can occur in only one way. And the latter one can occur in more than one way. So there is a compound event, the former one is a simple event. Another example of compound event is getting a multiple of 3 in tossing a dice. A multiple of 3. So there are again 2 values, 3 and 6. Among 1 to 6, there are 2 values, 3 and 6. Both are multiple of 3. So here also I can win in more than one way. So these are compound event and simple event. So we discussed about random experiment, sample space, events and types of events, simple event and compound event. Now talking about events, there are another 2 very important terminologies linked with these events, which are mutually exclusive and exhaustive events. These are very 2 important terminology, mutually exclusive events and exhaustive events. So what do we understand by these exclusive and exhaustive events? By exclusive events, we mean that 2 or more than 2 events are exclusive. By this statement, we mean that they cannot occur simultaneously. The 2 events cannot occur simultaneously. Then they are said to be exclusive. They can never occur together. Then they are exclusive. For example, in case of tossing a coin, the events head, tail, they are mutually exclusive because they cannot occur simultaneously. In the same toss, you cannot get both head as well as tail. Only one result will occur. So they are exclusive events. In case of throwing a dice, even phase and odd phase, these 2 events are also exclusive. Because whenever you throw a dice, whatever number you get, that cannot be even and odd at the same time. Either it will be even or it will be odd. It cannot be both at the same time. So these are exclusive events which cannot occur simultaneously. But we can define events which are not exclusive. Not exclusive means they can occur simultaneously. For example, let person A and person B tosses a die. And the condition is, if even phase occurs, then A wins. If even phase occurs, then A win. And if a multiple of 3 occurs, then B win. And let 6 occurs. The result is 6. Then 6 is even, as well as a multiple of 3. So here both the conditions are satisfied. So both of them win together. As you see here, both A and B win together. So these 2 events, even phase and multiple of 3, they are not exclusive. because they can occur simultaneously. If 6 occurs, they can occur simultaneously. So if there is a chance that 2 events can occur simultaneously, even at least once, then they are said to be non-exclusive events. Otherwise, exclusive events means they cannot occur simultaneously. Now the next concept is about exhaustive events. 2 events or more than 2 events are said to be exhaustive. We say they exhaust each other if their union, you must be familiar with the term union, intersection in set theory. If their union means if I consider them together, if their union covers the entire sample space, that is, no event other than them can occur. No event other than them can occur. So they cover the entire sample space. Then such events we call mutually exhaustive. Likewise, in the previous example of tossing a coin, the event head and tail, they are also exhaustive. Why? Because whenever you toss a coin, either you will get a head or a tail. No other outcome is going to come. Either head or tail will occur. Likewise, in throwing a dice, even phase, odd phase, these 2 events are again mutually exhaustive. Even phase and odd phase. Because even phase contains 3 possible outcomes, 2, 4, 6. And odd phase contains 3 possible outcomes, 1, 3, 5. Because if you toss a dice, total we have 6 outcomes, 1, 2, 6. So even phase and odd phase, if you put them together, you get the entire sample space from 1 to 6. So they also exhaust the entire sample space. So even phase and odd phase in tossing a dice are also exhaustive events. Head, tail in tossing a coin are exhaustive events. But getting an even phase and getting a multiple of 3, they are not exhaustive. They are not exhaustive because even phase contains 3 points, 2, 4, 6. Multiple of 3 contains 2 points, 3 and 6. So if you join them together, if you consider their union, the entire sample space is not covered because 1 and 5 doesn't belong to either. 1 and 5 doesn't belong to either of the group. So they don't cover the entire sample space. So they are not exhaustive. So these are the ideas of exclusive and exhaustive events. In this video, let me keep it up to here only because I want to make my video short so that you don't feel bored, or rather you can grasp the concept easily. And we shall continue further discussion in the coming videos. If you have any questions or queries, you can ask me in the comment section, and it will be of great help if you like the video and subscribe to my channel. It will help my channel to grow. Thank you all for watching my video, and I hope the video will be helpful to you, and we shall meet soon in my next video. Thank you all.